Yeah, welcome back to the Masters Academy. Today we are going to discuss about the electricity chapter, lecture number 4. Okay. In this lecture, today we are going to discuss about the some symbols which are very important to know about that how to connect those symbols in parallel or series and what they represent actually, and which device is used and what to measure. For example, to measure the current, which device is used to, and as well as to measure the voltage, which device is used to measure the induced current, okay, like galvanometer, ammeter, voltmeter, and resistance. So how do we connect them, and whether they should be connected in parallel or series? Okay, so these details we will discuss in this today's session. For example, look at the symbol here. For hospital we are having a symbol plus symbol. Plus symbol is for emergency purpose, is it right? So like that, in our circuit of television you can see that this is a motherboard. In this motherboard, we're having a lot of symbols are there, which are small devices are there, which represents how to flow the current. This represents actually main purpose is to the amount of current which is required to the particular device. For example, screen is required some amount of current, and then speakers require some amount of current. Is it right? So for each different appliances devices in this, so in the all directions the current will flow, but as a requirement only, but not more or less. So that's why we use resistors here. Different resistors are there. You can see that here. Okay, the capacity of resistance required is also mentioned in this circuit. Okay, to make a drawing of the circuits easy, let's learn electrical symbols first to how to connect those symbols. Okay, first of all, look at the symbols of electricity. The first one is cell, and this is the basic basic picture of the symbol. How to represent the cell in a symbolic form is like this. So one side is positive and another side is negative terminal. So both together here you can see that this is a positive terminal and this is a negative terminal. This is what we call a cell. Okay. Now battery. So when we connect two or more cells together, then we call it as a battery here. So this is one cell and another cell. If you connect one cell, the negative terminal of the first cell with the positive terminal of the next cell, and this is negative and this is positive and this is negative, this is positive. They have to connect. We have to connect these all the cells in a series combination. Okay. So once the more two or more cells together connected in a series combination, then we can call it as a battery. Okay. So this is like this, the series combination of the cells. And keys are switches. Now look at how to represent the key. There are two types of keys. One is plug key, another is a bracket key. Like you can see that. So this is a plug key. If the plug is inserted here, then we call it as on. Switch is on. Okay. So here closed. Closed means on. Plug key is closed here on. Like this. This is the plug key which represents, and this is the plug. If we remove this key, okay, then it will be open circuit. Open means no power supply, it means off, switch off. Okay, here it is inserted, so it is on. You can see this. And open means plug key is open, it means off, there is no key in that. Okay, and another type of key is tap key. Tap key is always like this. So here it is closed when it is touches both the terminals positive and negative. So this is closed and it means it is switch on. Okay, you can see this. And this is open, it means switch off. Okay, so these are the types of keys: plug key and tap key. Now symbol or resistor, you can see that this is a color of the resistor represent different capacity of the resistance. Okay, this is the symbol of resistance. Always remember how to draw this means draw a straight line and a zigzag. Either you can start from the bottom or top, simply look like this. And whenever it is starts from top bottom half, you have to end from the top half, so that it will be represents like this. So this half is at the top and this half is at the bottom, so that it will be a complete cycle of a resistor. Okay, so this is the symbol of resistance. And this represents variable resistance. Variable resistance means this is the whole value of resistance only. You can change the value of resistance by moving this knob. Okay, so as per our requirement we can change the value of resistance. The symbol of resistance will be like this, and simple resistor only, but at the top of this resistor symbol we will have a arrow mark symbol. This arrow mark represents variable resistance, is also known as a rheostat. What we call it as a rheostat. Okay, and this is variable noun resistance. Whenever the value of resistance, variable resistance is fixed, so we call it as a variable noun resistance. Variable noun resistance symbol is like this. Okay, we'll keep an arrow mark with 90 degrees here, and this is what we call where we can see the resistance in our daily life. A regulator of the fan. Okay, and to supply the sufficient current and to increase or decrease the speed of the fan, and here washing machine, and then mixie. Okay, so measuring instruments, ammeter. Okay, negative terminal and positive terminal. Here you can see that the symbol represented here is A for ammeter. Okay, symbol is this one. Okay, positive terminal and negative terminal with letter A. Next one is voltmeter. Same here, negative terminal and it is positive terminal, and the same symbol with the V letter in this. Okay, positive and negative. Okay, this is voltmeter. Next, galvanometer. Same here, you can see that galvanometer is used to measure only induced current. Induced current. Okay, so if it deflects either positive side or negative side, so that we can say that the some current has been induced in the conductor. Okay. Now look at these symbols once again. I can take a screenshot of this screen. So a battery, a cell, plug key, tab key, which is open and on, open, which is off, and close, which is on, and resistor, a variable resistor, and what we can say another is a variable noun resistor. Okay, ammeter, voltmeter, and galvanometer. Is it clear? Now this symbol represents a wire joint. Okay, crossing of you can see that a wire joint, one wire is connected with another wire here. This is a joint which represents like this is the joint of the two wires, so simply we call represent like this joint. And this is a crossing of wire one over the another. Okay, they are not connected with each other, they are different wires but they are crossing by one over other. You can see the wire crossing. This is looks like this. So a black wire is crossing the red wire here in this picture. Is it right? So this is what we call crossing point. Okay, and this is the symbol of a electrical bulb or electric bulb. Okay, electric bulb symbol is represented by like this. A simple structure is like this. Okay, and you can draw like this. This is electric bulb. Okay, it's test time. Simply draw the symbols of components required to make the circuit. Here, first structure is cell. So we have seen already cell, resistance, battery, ammeter, variable resistance unknown, variable resistance known, voltmeter, galvanometer, a plug key which is on, tab key which is on, a wire joint, electric bulb, plug key which is off, tab key which is off, and a wire crossing. So these are all symbols we have seen. Now you are tasked to draw these all. Okay. Now look at the a cell or resistance, a battery, ammeter, variable resistance which is unknown, variable resistance which is known, voltmeter, galvanometer, plug key, tab key, wire joint, and electric bulb, and plug key which is off, tab key which is off, and wire crossing. Is it clear? You can take a screenshot of this video or the screen. And some important points to remember. Always keep it in mind. Here, batteries, to form a battery while connecting the cells. to each other always connect, unlike terminals. Negative terminal with positive terminal or positive terminal with a negative terminal. We should not connect the like terminals of each battery here. Okay, because we have to connect the cells in the series to form a battery here. Okay, one more is ammeter, which is having the direction of current always from positive terminal only, positive terminal to negative terminal only. In the ammeter, the current should not flow from negative terminal to positive terminal, otherwise it won't shows any reading. Voltmeter, here it is the positive terminal to negative terminal only as it is. But ammeter always connects in series, whereas voltmeter always connects in parallel. So for the devices like ammeter or voltmeter, the side from which current enters is positive and the side from which current exists is negative. Okay, which is very important. And ammeter always connects in series, whereas voltmeter always connects in parallel. Some important point to remember here, one more point is, you can see that the current direction is this, is it right? So here ammeter is placed. So the ammeter positive terminal should be in this direction and negative should be here. Is it right? So that is where it means this ammeter is connected in a single line, that is straight line of the circuit. It means it is connected in series only, within the line only, but not out of the line. So ammeter always connects in series. As this current in the circuit is not divided, okay, the current has been not yet divided in this circuit anyway. So the ammeter is connected in series with the cell. Is it right? It has very low resistance. Ammeter resistance is zero, for example. Okay, it has very low resistance. So it allows almost entire current to pass. Entire current to pass. The amount of current which is coming from the battery, so it will allow the whole current to pass through it because it has zero resistance. So it does not disturb the current as well as measure the current. So the amount of current which is flowing through this circuit, okay, whole amount of current is flowing through the same ammeter here because it is having zero resistance. The amount of current which is coming through this device, it will measure the amount of current by the deflection of this needle. Okay, and it does not disturb the circuit at all because the current is not getting divided anywhere. So no problem with this ammeter, so that we can connect this device in series with the cell to measure the amount of current flowing through the circuit. Is it right? Now you can see that apart from that ammeter, we have connected one more device, that is voltmeter. We can connect anywhere in the circuit because, but we should not connect within the circuit. We have to connect away from the circuit by at any 2 points. Here, these are the two endpoints of this voltmeter. Okay, it is not connected in the circuit directly. It is connected to the circuit parallelly. So here, current has getting divided here. Okay, so some amount of current is going this side and some amount of current is getting divided. So this voltmeter used to measure voltage of the circuit, voltage. Okay, when current gets divided, there is no chances to it's dividing of voltage. Voltage will be the same in the circuit when the current gets divided. Okay, it doesn't affect the current flow, but can measure the flow of voltage here. Okay, so voltmeter always connects parallel to the circuit. So here this is a circuit line and it is parallel to the circuit here. Is it right? As the current in the circuit is divided at point A, so voltmeter is always connected with in parallel with the cell. Okay, this is a voltmeter symbol and it shows the deflection to see the how much voltage is there in the circuit. Okay, it is made from a material having infinity resistance. So it has infinity resistance so that it can oppose the complete current. Okay, so the current is always allows the negligible or almost zero in this. So which device is having infinite resistance? Voltmeter. Which device is having zero resistance? Ammeter. Okay. How is voltmeter connected in the circuit to measure the potential difference between the 2 points? We know that voltmeter always should be connected in parallel only to the circuit to measure the potential difference across the 2 points. So to measure the potential difference between 2 points, voltmeter must always be connected in parallel to the circuit or points. What happens if ammeter is connected in parallel? We know that if the ammeter connected in parallel, it has zero resistance. Is it right? It allows the complete current. So there is a chances of getting blast or getting short circuit. So if ammeter is connected in parallel, the resultant resistance of the circuit decreases and the more current passes through the ammeter. Hence, the ammeter is likely to be bond. Okay, we should not connect in parallel. What happens if the voltmeter is connected in series? As we know that voltmeter is having infinite resistance. If we connect in series, it does not allow the current to pass through it, and there is no power supply or there is no current supply in the circuit. When the voltmeter is connected in series, the resistance of the circuit becomes high and there is a considerable fall in the current through the circuit. Thus, the voltmeter will not be give the correct reading. Is it right? Of the potential difference because it won't allow the current to pass through that in the circuit, so we won't get the correct reading of the potential difference. How many mistakes can you find in this diagram? Yeah, here first of all, voltmeter is connected in series to the circuit and ammeter is connected in parallel, so we have to replace these two. Battery, current is flowing. So here, which is voltmeter, we have to place here instead of voltmeter we have to place ammeter because it is in series to the battery directly before the current gets divided. So we have to replace this with battery ammeter, and here current gets divided. So we have to replace this ammeter with the voltmeter, and then we have to place the plus symbol and minus symbol here, plus and minus. Okay, and here we can place this resistance, variable resistance or resistance like this. Okay. So this activity is very very important. Experimental verification of Ohm's law. We know that Ohm's law states that voltage across 2 points of the circuit is directly proportional to the current in the conductor. Is it right? So as we know that V is directly proportional to I, V is directly proportional to I. So what we can do here is we have to verify with the some experiment, some values and some readings. Look at here, v is directly proportional to I. Then if you remove that proportionality constant, v is equal to I r. Then if I is, if you get on the left hand side, we will become v by I is equal to r, which is constant. Is it right? So this is what we call a resistance. So we have to prove that the ratio of voltage to the current is always constant. Okay, that is the resistance. So in this experiment, we have to prove that V by I is equal to constant. Like if we take different values of voltage, V1 by I1 or V2 by I2, V3 by I3. Okay. So like this, we have to prove that these all values are constant. Okay. So we have to prove this by taking different values of voltage and current. So this is the conductor, okay, nichrome wire of length 3 meters and diameter 0.02 centimeters. Okay, and this is wounded over this circumference of this rod. Now it is looks like a resistor. You can see that ammeter and a plug key and a battery has been connected here to the circuit and a voltmeter across the terminal of the resistor. Now when the current flows from the battery, you can see that the voltmeter gives the voltage reading and the ammeter gives the current reading in the circuit. So here first number of cells is only one. Current flows through 1 amp. Current flows is 1 ampere and potential difference is 2. So here resultant ratio voltage to the current 2 by 1 is equal to how much? 2. Okay. Now cells has been increased. Automatically what happens? Current gets increases. So number of cells 2, current is doubled. Potential difference is also doubled. Okay. Then ratio is 4 by 2, that is also equal to 2. The number of cells 3, the current is gets tripled and potential difference also gets tripled like 6, and this is also the constant. Okay, so from this what we can conclude that as the current increases potential difference also increases and the final their ratio is always becomes constant. Is it right? If the number of cells 4, then also what happens? The current gets doubled four times, voltage also gets 4 times, 4 and 8. So 8 by 4 is also again constant. So we will see that graph how it looks like for the conductors. On the horizontal line, we have drawn that voltage and vertical line current. No problem, we can draw an opposite also. It does not affect this graph. So here 2 1, 4 2, 6 3, and so on. So the line is always representing a straight line, which is a linear equation type. Okay, linear line. So this is what we can say. Current in a conductor is directly proportional to the voltage from this graph. This is a very important activity. So many times this question has been asked in the previous year papers of the board exam of CBSE and as well as NCRT and other state boards. Okay, so the graph of the current in a conductor to the voltage across the 2 points is always a linear graph. Okay, thank you. So we'll discuss the problems based on these concepts in the next session.